Good morning, dear students. We are discussing Unit 5, that is preparation properties, structure, and uses of the following compounds. And our today's topic is silicones. So, dear students, what are silicones? Silicones are polysiloxanes or organosilicon polymer. The general formula is R2SiO. This formula, that is R2SiO, is similar to that of and the empirical formula of a ketone, which is R2CO. That's why these are named as silicones. Since ons suffix is used at the end of the ketone, and similarly we can use silicones as their name. These silicones may be linear or they may be cross-linked. These silicones are also called as high temperature polymers. Why? Because they are very stable or thermally robust at higher temperature. Now the preparation of silicones, how these silicones are prepared. Basically these silicones are prepared by the hydrolysis of dialkyl dichlorosilane or diaryl dichlorosilane, depending upon the product what we want. Whether we want alkyl substituted silicones or aryl substituted silicones, we take same type of the starting material. This dialkyl dichlorosilicon silane is obtained by passing the vapor of an alkyl chloride or aryl chloride over silicon in the presence of copper as catalyst and at 570 Kelvin. As shown in the reaction, we get the product dialkyl dichlorosilane or diaryl dichlorosilane. This dialkyl dichlorosilane or diaryl dichlorosilane upon hydrolysis yields a straight chain polymers which grows from both the sides. So as evident from this reaction series, we have taken dialkyl dichlorosilane and we have treated it with water and we got R2SiOH whole twice. This R2SiOH whole twice, it condenses with another molecule of R2SiOH, and with the loss of water we are seeing that the chain is increasing. The product so obtained further upon condensation with another molecule of R2SiOH gives a long chain of this alkyl silicones. Since at both the end we are seeing that there is an active OH group is left at each end of the chain, this polymerization reaction continues to any length of the chain and give a long chain product as shown below. Further, here we are discussing about chain silicones. Now, how a cross-linked polymer of these silicones are obtained? This is obtained by the hydrolysis of monoalkyl trichlorosilane, which is shown in this reaction. Initially, this monoalkyl trichlorosilane upon hydrolysis gives RSiOH whole thrice and 3 molecule of hydrochloric acid. This RSiOH whole thrice, it condenses with 2 or 3 molecules of the same type of this RSiOH whole thrice and gives a long chain like polymers. This chain then undergoes cross linking with another chain of molecules, and upon hydrolysis we get a cross-linked polymer of this silicone. Since we are still having OH group at the periphery of the chain, we can extend its length to any dimension in any manner. Now the types of silicones, we are having linear silicones, cyclic silicones, and cross-linked silicones. These linear silicones, these are obtained by the hydrolysis and subsequent condensation of dialkyl or diaryl silicon chloride. And the example among the linear silicones are silicone rubbers, silicone resins, etc. Whereas the cyclic silicones, these are obtained by the hydrolysis of dialkyl dichlorosilane. Moreover, the cross-linked silicones are obtained by the hydrolysis of monoalkyl trichlorosilanes. As I have already discussed the cross-linked silicones above. Now the properties of silicones. Since we are having organic side groups surrounding the silicones at the periphery, so all the silicones are water repellent, they are thermally robust, these are electrically insulators, and chemically they are inert, they don't undergo much reactions. Since some lower members of silicones, they are oily liquid, whereas higher silicones having long chain structures, these are waxy solids, their viscosity remain constant and does not change with temperature even during the winter. Moreover, silicons are resistant to attack by acids and bases. These are not readily combustible, and they are hardly affected by the exposure of UV radiations. Solid rubbery silicones, they retain their plasticity even at low temperature, and these are resistant to many forms of chemical attacks. So based upon these properties, these silicones are very useful in our daily life. For example, silicones, these are used for low temperature lubricants in vacuum pumps, high temperature oil baths, etc. Moreover, these silicones may be used for making waterproof clothes, silicone greases, sealant, varnishes. They can be used as insulating material in electric motor and other electric appliances. These silicones, they can be mixed with paints and enamel to make them resistant toward high temperature sunlight, dampness, and chemicals. They have high dielectric constant, so they are useful for electrical condenser. Moreover, they can be used in cosmetics, like these forms the important component of shampoos and conditioner, which improves the softness or silkiness of hair. Moreover, they can be used in shaving foams, toothpaste, antiperspirant, cosmetics, hair styling gels, etc. So we are having number of uses of silicones. Thank you. I'll see you in the next video.